Hello again, welcome back. Further mechanics, A-level. A particle P of mass 0.5 kilograms is moving with velocity 4I plus 3j meters per second. When it receives an impulse j newtons. Immediately after receiving the impulse, P is moving with a velocity minus I plus 6j meters per second. A, find the magnitude of j. So, in order to find the magnitude of j, we need to know that impulse, and let's write this down, impulse, so part A, impulse is equal to mv minus mu. Now, we could use vectors here. There's multiple ways of doing this, but I'm going to use vectors. So, is equal to, the 0.5 is the mass, and minus 1 and 6 is the impulse P. So that's the final velocity, and minus the mass times the initial velocity. So minus 0.5, and we have vectors 4 and 3. And this gives us minus 0.5, minus 0.5, and 3, and minus 2 and 1.5. So that gives us 2 and 1.5. And this will be equal to, minus 0.5 minus 2, that's minus 2.5. And 3 take away 1.5, well, that's just 1.5. And to find the magnitude, well, we've got the root of, so magnitude is equal to, so magnitude is equal to the root of, and well, that's 2.5 all squared plus 1.5 all squared. And this will give us 2.92. 2.92 on your calculators, that's to 3 sig fig. Now, they haven't specified a degree of accuracy or precision, but 3 sig fig should be good to go. Part B, and if I extend the page here now, part B, it says, and let's just recall what it says, the angle between the direction of the impulse and the direction of motion of P immediately before receiving the impulse is alpha. Find the value of alpha. Well, in order to do that, we need to construct a diagram here. So the initial impulse of 4 and minus 3, and I should have put an arrow on that. 4 and minus 3. Let's just put an arrow there. So that would be, 4, 3, not 4 and minus 3. So that's 4, 3 as a vector, 4 along and 3 up. And then we have minus 1, 6. Minus 1, 6. So minus 1, 6. So we got something like that there. And minus 1, 6. And so we have minus 1 and 6 as a vector, and then we have the impulse I, the impulse which is minus 2.5 and 1.5. Let's just construct this here, and okay, that's good to go. And we have I, which is equal to minus 2.5 and 1.5. So we've done our construction here, and let's see how we fare. So I just stick an arrow here, because it's in that direction, and this is in this direction, an arrow here. Okay, so now how are we going to go about doing this? Well, you could use dot products, you could use other ways of doing it, but simple geometry here, and using SOHCAHTOA. I'm going to use there you go. There's my first triangle. Just going to draw triangles. There's my right angle triangle. And of course, this will be 1.5, because that's 1.5. And this will be 2.5. And that's 2.5. Therefore, if I do a tangent, because we need to find the angle, and this is the angle that we need to find here, and the angle between the impulses, which will be good to go. So the tan to the minus 1 of 2.5 over 1.5, because opposite over adjacent, will give me the tangent of the angle, and that gives me 59.04. 59.04. And if I just extend this line now, just extend this and draw this to here, and this gives me what? Well, that's 4 along, and all of this is 3 up. And if I do tan to the minus 1, or inverse tan of 4 over 3, that gives me 53.15. And therefore, I can say alpha is equal to 53.13 plus 59.04 plus 59.04, and that gives me the value of alpha, which is equal to 112.1. 112.1. And that's 7 marks.